Hey there! Mia here! We've all been there before. You're learning something in school when you start scratching your head, wondering, why is it so important to learn this anyway? I promise you, there is a good reason for learning all of the different things we do. From learning about the past, shout-out history lessons, to learning about the very world around us. There's so much to learn. But that doesn't mean there aren't times when we wonder, why do we need to learn something? For me, it's usually when it comes to math. I mean, I don't have anything against numbers, but sometimes I do wonder why we need to learn so much about them in the first place. But then I remember, just like science, math is everywhere too. Sure, it's at the store when we spend money or the restaurant when we try to figure out how much money to leave as a tip. But it's also in every building or bridge you see. Architects rely on math like geometry and algebra to accurately and safely design the blueprints for these types of construction. And then there's calculus. This brings me to the topic of today's lesson. So let's kick off today's lesson with an undeniable truth. The world is constantly changing. Don't you agree? I mean, the earth moves, time moves, objects move, we move. Everything is in motion and things are constantly changing and evolving. That's where calculus comes into play. Now, before we dive in too deep, let's take a quick look at the history of calculus. And it's still kind of up for debate. Let me explain. Unlike other math functions that are truly ancient history, calculus wasn't discovered until the late 1600s. Now, I know that might sound ancient to your eye, but in the world of mathematics, calculus is relative newish. It was discovered in the late 1600s by mathematicians Isaac Newton and Gottfried Leibniz. The craziest part? They weren't even working together. That's right. They each discovered calculus on their own around the same time. How wild is that? And while there may be some debate around which of those two men is the true father of calculus, there are more important things we can learn about this field of mathematics. So, let's go ahead and put on those curiosity caps and dive into calculus. Like, what even is calculus? And why is it so important anyway? And how and where is it used in the world beyond the classroom? But first, here's one more calculus fun fact. The word calculus comes from the Latin word for pebble. Why? Well, the Romans used to use pebbles as mathematical manipulatives as they figured out different equations or computations. Can you think of another mathematical tool that sounds similar to calculus and is also used for computing mathematical problems? You've likely used one before. Perhaps even one that was built into a phone to help quickly solve a mathematical equation. Any guesses? That's right, a calculator! Okay, now back to calculus. Before jumping into the world of calculus, it's important to have a solid foundation in the world of algebra, geometry, and trigonometry first. So, if you don't yet know what those are, that's a good place to start. But don't worry, this lesson doesn't get too far into the nitty-gritty of calculus. It's more about learning what it is, how it's different from other math, and where it comes in handy in the real world. So, no matter what level of math you're at, consider this your invitation to jump aboard for this particular calculus lesson. Now, what even is calculus? Well, for starters, it's very different from the math you've learned so far. Why? Because calculus is all about dealing with change. Let's take a look at this example. Let's say you're out riding your bike. You ride your bike at 15 miles per hour. If you drive for 3 hours at a constant speed, some simple multiplication can tell us you will ride a total of 45 miles. But when do you really ever travel at a constant speed for 3 hours? First of all, it takes some time to build up your speed to get that 15 miles an hour pace. You literally start from 0. And then maybe you stop for some water or slow down to give your lungs a break. Maybe you slow down going up a hill or speed up going down. There are so many variables and changes that impact your trip. So let's get back to your bicycle adventure. The reality is, you're speeding up and slowing down throughout your journey. In other words, your speed is changing. It's not staying constant. While a constant speed might make up for a simpler math problem, that's simply not realistic. So, to best and most accurately predict how far you could travel on a bike with those changing speeds, we would have to turn to, you guessed it, calculus. You'd have to understand the relationship between the distance traveled and the speed at which you traveled, and all of the changes in between. So, when it comes to understanding changing relationships, calculus can help do just that. And in order to do that, calculus relies on its own little tool belt to help. Now, in this tool belt, there are several different functions that help understand, determine, and predict these relationships, and 3 very important tools that help explain these relationships. There are limits, which help when trying to describe how a function approaches a value. There are derivatives that helps explain how a function changes. And then there are intervals, which help determine the area of a curve underneath the function. And where there are other components to calculus, these are the essential foundations to this type of math. Using these 3 foundational tools, mathematicians can solve a wide variety of problems. And it's not just mathematicians who use it. People working in the realm of modern science and technology, and even in the world of modern medicine, rely on calculus to get their job done. Now, calculus is the overarching term for this type of math. Upon closer investigation, you'll learn there are 2 types of calculus. There's differential calculus and integral calculus. Let's take a closer look at each. Let's start with differential calculus, which focuses on the derivative of a function. Let's take a look at a function. For example, in y equals the function of x, which would be written like this: y equals fx. That just means that the value of y of the function changes relative to the change of the variable x. Differential calculus studies the behavior and rate of how different quantities change. In other words, it measures the rate of change of a function at any given point in time. In algebra, you can calculate the rate of change by determining the slope, or change in y divided by the change in x. But since calculus deals with changes in curves, not consistency in lines, the slope equation won't quite do it justice. That's when we have to turn to the derivative. When a change is constant, we can map out changes in a nice and neat and very straightforward graph. The path of change here is linear. Therefore, the function is a linear function. But, as I mentioned earlier with the bicycle example, there are many changes in life when change isn't linear. That, my friend, is where differential calculus comes into play. Differential calculus deals with the derivative of a function. In other words, it studies the behavior and rate at which a quantity, like distance changes over time, like when you're riding your bike. Differentiation analyzes the changing quantity, like speed, and makes predictions about the final results, like distance traveled. By finding the derivative, we are able to determine the rate of change at any given moment in time. Once the information is plotted onto a graph, that graph can be analyzed and used to make very accurate predictions for the future. Okay, now let's pause for a second for a quick quiz. Which of these two graphs represents a constant and consistent change? Graph A. The giveaway? The straight line indicated a constant and consistent change. Let's take a closer look at graph B. The graph would look like this if the change varied throughout, like the relationship between the speed and distance when you're riding your bike. That's because the rate of change is always, changing as your speed changes. Now let's take a look at the other type of calculus, called integral calculus. It's basically the opposite of differential calculus. Integration helps describe the area or volume of a curve on a graph. Why does it matter? Well, it allows the calculation of exact area and volume. Now, since these two branches of calculus are inverse of one another, if you find the differentiation of a function and then integrate it, guess what? You will be right back where you started in the first place. It's kind of like if you added 50 to 100, only to subtract 50 from that total. You'd be right back at 100, just like when you started. Newton and Leibniz. Remember those guys are the founders of calculus? Describe this inverse relationship in what is called the fundamental theorem of calculus. As mentioned before, the beauty of calculus is that it helps us form connections and relationships in our very dynamic or changing world. Calculus isn't just something we learn in school and never touch or think about again. It's used in science, technology, business, and even the medical world. Studying these changes, we are able to understand the changing effects of certain elements on systems like the weather. As the pressures and temperatures in the air change, there is a measurable impact on the weather. Calculus helps determine this effect. Have you ever wondered how a meteorologist was able to predict the weather forecast when it hasn't even happened yet? Well, now you know. Calculus. And it's not just weather. Anytime a quantity or a system is undergoing change, calculus can help analyze the system and impact of the change. That allows for an optimal solution to be determined and tested before being implemented for better results. Those tests are what allow people like meteorologists to predict the future of the weather or economists to predict the rise and fall of the stock market, for example. And that's not all. Calculus plays a role in science when it comes to determining when a space rocket can be expected to land on Mars. Businesses use calculus to predict profit and revenue. You can think of calculus like this. It's basically the language that helps describe our ever-changing universe. The list goes on and on when it comes to areas where models dependent on calculus come in handy. Who knew? Well, now you do. And someday, when you really dive into the world of calculus, you'll learn all about polynomials, trigonometric functions, exponential functions, and logarithmic functions. These are considered the building block for the more complicated functions you'll work toward as you learn more calculus. Then, you can start utilizing these functions together through addition, subtraction, multiplication, and even division. So, it can get rather complex. But if you start with learning the basics, it isn't as complex as it may sound to you right here and right now. And like learning anything new, Calculus comes with a learning curve. No pun intended. You'd have to put time and effort into learning the new terms and tools of this branch of mathematics. But there are so many incredible things that can come from calculus. It's helped us better learn, understand, and describe the changing world around us. Remember, it's helped us to create better and more efficient designs and make more accurate predictions in an ever-evolving world. Well, that's all we have time for today. But before I go, be sure to remember this. Math is all around us and plays an essential role in some pretty important things. So, keep that in mind the next time learning about numbers has you rolling your eyes. And hey, you never know. You might just need those numbers in your future career as an astronaut, economist, engineer, or even a software developer. So, thanks for tuning in, my friend. As always, stay curious, and I'll see you next time.
We are thrilled that you're watching Blue Studios 24/7. We're so excited to bring round-the-clock entertainment and educational content to your home. Don't forget to hit the subscribe button to stay up to date with our latest videos. At Blue Studios, we aspire to revolutionize the way families spend time together. We empower families by providing them with tools to work together, earn and learn, and achieve new heights of success. Visit www.bluestudios.io to discover more about our mission and how we empower families to succeed. Thank you so much for being part of our community. Keep watching and learning with us. And don't forget to hit that subscribe button.